Now, in this video, we are going to be looking at R squared. In our previous video, we've talked about a least square estimate using least square estimator. So when we get our least square estimator, because that is the genesis, when you get the least square estimator, then the next thing for you is to check the credibility of that least square estimator. For instance, now you have something like this: your y equals b naught plus b1x. Now, at this point now, we found b1 using least square estimator. This is our estimate now. This is our parameter. Now we have gotten this parameter, but can we use this parameter to determine the future of the y? No, it's not possible. We can't just do it like that. What you have to do is we still have to test the credibility of this parameter we've derived. Now it could be 0.09, it could be any value that we have gotten for this. We can't use it to predict for our y until we test even the answer. So that is where the R squared comes in. So R squared helps us to test the credibility, the goodness of fit of this parameter here, so that we can know if it is good enough to predict or otherwise. Now, what is R squared again now? R squared shows how close each data point fits to the regression line. If you quickly look at what I have on the board here, look at the points here. Look at the deviation. This is the data point. Then this is the regression line. Then you can see how far this data point here, this is my observation here, moves away from this line, and how this moves away from this point here, and how this moves away from this point here, then how this moves away from this point here, how this moves away from this point here. You can see. So that is the variation, that is the deviation. Now, the closer the data point to the regression line, the better the goodness of fit of the regression line. That is, if the data points, they are close to the regression line, it means that they are going to be very good to predict, because it means that they are the regression line is able to capture a lot of the characters of the y. Look at what I have here. At this point here, if you look at the deviation here, this is the observation to the regression line. See the point here, data point here to the regression line, data point to the regression line. Then you compare to the data point to the regression line here. You see that this is closer to the regression line, than this. That means that this is good enough for us to predict, because the data points are close to the regression line. So the bottom line, or let me just put it this way, that in a simple way, when the data points are close to the regression line, it is better to predict the character of the y. But when it is far away, that is a problem. It's a problem when you are predicting with that kind of parameter. Now, that is why we say that our R square explains how the regression line predicts actual value, because if regression line can explain to all the total variation of y in respect to the variation of x, because these are the variations. It is this R squared that will explain the variation of the y. So when we know the variation of the y, when we know the variation that the y can capture, or the variation which the regression line can capture, then we can know whether it's good for us to predict. But let me quickly tell you this. When you talk about R squared, it has to do with the R correlation. That is the coefficient of correlation. In the previous video, in our, I think like 2 or 4 videos which we have done, before this particular one, we treated correlation and we used R correlation, that the coefficient of correlation. That coefficient of correlation, which is R, that R is what we squared here. The only difference is that R, the answer of that, the value of that R falls between -1 to 1. But this one falls between 0 to 1. So your R square value falls between 0 to 1. Now, when your R square value falls between 0 to 1, so when your answer is something like this, 0.06, if you don't understand how close is this to 1, because some people might not really understand that, they are not very good in mathematics, but if you don't understand how close is 0.06 to 1, then just take it to percentage. 0.06 times 100 is going to be 6%. So it means that this regression line is capturing just 6% of the variation, is capturing 6% of the characters of a Y. And when you capture just 6% of character of a particular person, it is going to be very difficult for you to explain the character of that person or to predict what it's going to do in the future. That is a fact. Unlike this, where you have 0.95, then when you convert this to percent, it's going to give you 95%. Imagine you have a friend and you know 95% of his attitude, then it's going to be very easy for you to predict that person. That is just what we are trying to say. So when you know 95% of variation of a particular dependent variable, then it's going to be very good for you to predict it. So in a simple way, the closer the data points to the regression line, the better it is to predict. And when it moves away, from the regression line, then that predictability becomes less. Now, if you look at, there can be a situation whereby, let me put, where can I put that? A situation whereby you have something like this. This will happen when your answer is 1. So when there is no data point and no data point here, it means your answer will exactly be 1. So just when you're writing exams, we are giving 0.95, convert it to a percentage, you get how close. So how close that value is to 100% will tell you how good is the regression line to predict the Y. And when it's just this way, maybe your answer is 1, that means it's just perfect. It's just perfect. But when it's 0.05, 0.0 something, you have to be very careful in using that to predict, Y in any kind of phenomena. Please subscribe and get more of our videos.